to question number 3 then. You're given some information, you're given the frequency, and at a distance of 25 millimeters from the equilibrium position, its velocity is half the maximum velocity. Calculate the amplitude and the maximum acceleration of the body. So we're talking about maximum velocities and maximum accelerations in this question. And it's worth remembering, if we just think of this simple harmonic motion, and here it is, this thing is oscillating at the peak. So that's when x, the displacement from its rest position, is equal to r, in other words. At that peak, we get the maximum acceleration. So that's worth remembering, okay? So this is telling me that at maximum acceleration, x will equal r. So remember that, okay? And the other bit of information, the key bit of information is, we used already in question number 2, when the velocity is maximum, the displacement is 0. So that's 2 important parts of this cycle. Maximum velocity occurs when the displacement is 0 at this point, and maximum acceleration occurs when the displacement is equal to the amplitude r. So those 2 bits of information are going to help us here. We're also given that at 25 millimeters, v, the velocity, is half of v max, so we can write this. But we know that v max equals omega r, and we also know that v equals the square root of, well, from the formula sheet, v equals omega times the square root of r squared minus x squared. So we can plug those 2 bits of information into here. We can say that omega times the square root of r squared minus x squared equals v max, which is omega r, over 2. So we've now got a formula where we know x, we know omega, or we can find omega, because it's 2 pi times the frequency, and we know the frequency, and therefore we can find r, which is the amplitude, by rearranging this formula. So see if you can go through the algebraic steps and then get r on its own, and we can calculate what that is. First thing I would do would be to cancel out omega from both sides. So it actually turns out that we don't need omega, because omega cancels. So we've got the square root of r squared minus x squared equals r over 2. Square both sides to get rid of the square root sign. It cancels out. Omega cancels out. So squaring, we get r squared minus x squared equals r squared over 2 2's are 4. Timesing both sides by 4, we get 4r squared minus 4x squared equals r squared. So timesing everything through by 4, we get to here. Subtracting r squared from both sides, we get 3r squared minus 4x squared equals 0. Adding 4x squared to both sides, we get 3r squared equals 4x squared. So dividing by 3 and square rooting. So knowing x, which is 25 millimeters, or 0.025 meters, we can find the value for r, which is the amplitude. Once we know r, we can put that into the formula for the maximum acceleration, because at that point the displacement is r. So we can use the formula for acceleration, which is omega squared r, to get, or x rather, to get it. Okay? So see if you can complete from there, taking it from here. And in an exam situation, of course, I'm not going to be testing all this algebra, but here is the formula at the end. Use this formula to find out what the maximum acceleration is. So do you understand this, in other words, that the maximum acceleration occurs when the displacement is r? And then maybe further, can you derive where this formula comes from for further marks? So although I'm not testing particularly for the algebra, it might come in. I'm not giving you a strong hint here, I'm just saying that even if there is a lot of algebra involved, I would give the solution so you can carry on and do the question. Okay? So see if you can now calculate r using this formula and then plug that in to find the maximum acceleration. R turns out to be 0.029 meters, so plugging that in, maximum acceleration occurs when x, the displacement, equals r. So we put it into here and we can find a, which turns out to be 458 meters per second squared.